Now look at the 2002 complex number sum. Complex number z is given by z equals x plus iy, x greater than 0, y greater than 0. What do you mean by that? That means this complex number is in the first quadrant. The points A, B and C in the Argand diagram correspond to C, 2IC and C plus 2IC respectively. Plot the points A, B and C and determine angle AOB and tan AOC. Right? We have to plot these complex numbers and find AOB and tan AOC. For z equals x plus iy, you are given that x greater than 0, y greater than 0. That means the complex numbers x plus iy or c is on the first quadrant, right? First quadrant, like this. What is IZ and 2IZ? What is C plus 2IZ? IZ is, how do you obtain IZ?
IZ is the 90 degrees from the Z modulus. 90
You have to
degrees.
rotate OA by 90 degree, no? Anti-clockwise
Yes,
direction. Then you can have, let's say, A dash. So this IC, right? If you double this one, so this 2IC, right? This IC, this 2IC, okay? Then C plus 2IC, so you have to construct this rectangle, no? This point. This is point C. Okay? Point C. OA. So this is B. This is C. Right? What is AOB? What is the angle AOB? AOB is clearly
so 90 degrees.
90, yeah, 90 degree, that is pi by 2. What is tan AOC? This angle.
So 45.
Not 45. Tan AOC equals AC divided by OB. OA. AC divided by OA. But AC equals, this length equals OB, no? OB divided by OA. What is OB? OB is magnitude of 2IZ. OA is magnitude of Z. This equals 2 into 1 into magnitude modulus of Z. This modulus of Z, this get cancelled, this equals 2. Then tan AOC equals 2. Okay? Tan AOC equals 2. Is it clear?
Yes, sir. Yes, sir.
Yeah. First part, if C lies on y-axis, so what can you say? The real part of C plus 2IC equals 0. What is the real part of this complex number? What is G plus 2yc, right? So if you simplify this one, x plus iy plus I times 2x
minus
plus
2y.
2iy. So this equals, what is real part? X minus 2y plus I times
2x
y
plus
plus 2x. Okay.
Yes, sir.
So, but real part is, what is real part is x minus 2y. Then this is the relationship, then x minus 2y equals 0, that is x equals 2y. So this is the relationship in x and y, right? In x and y. So what is the second part? What is the second part? Second part. For the second part, if y equals 2x, so that the point representing the complex number c squared lies on the line OC, right? Let's see how you can show that. If y equals 2x, what is z square? That is x plus iy whole thing square. That is x squared plus 2xy I plus I squared y squared. So this equals x squared minus y squared plus 2xy times I. So y equals 2x, x squared minus 4x squared plus 2x times 2xi. So you can substitute for y, then minus 3x squared plus 4x squared I. So you can take x squared out. So this equals minus 3 plus 4i. Okay? 3 plus 4i. This is squared. What is complex number? C plus 2yc. So we simplify this one. X plus iy plus I times 2x plus 2yi. So this equals x minus 2y I 2y x minus 2y plus I times y plus 2x. If you replace y in this one, why did you select this one? This is a complex number represented by c. But if you want to show that c squared also on c, on the line OC, so you have to simplify and check the complex number represented by the point c. Is it clear? That's why I choose this complex number, right?
Okay, sir.
Because this is a complex number represented by the point c, right? So what is c? So we have to check. Actually, in this sum way, three parts are independent parts. First part is independent from the second part, right? No, there is no interconnection, because for the first part they said point C is on y-axis, right? Then when you come to second part, you have to ignore that one, first properties of the first part. Is it clear the way, right?
Yes, sir.
Then now. If now they are telling this one, see y equals to x, only relationship that one for the second part, right? Then this is a complex number represented by z, right? The first part things you cannot use for this one, right? X minus 2y I y plus 2x. Then if you substitute x minus, for y you can put x, then 4x plus I times 2x plus 2x. So again you can take x out, minus 3 plus 4y. What can you say about that? Now c plus, now you can connect these two, no? C plus 2yc equals x times, instead of that x times z squared x times this equals c squared. If you connect these two, no, by 1 and 2, by 1 and 2 you can build, you can construct this relationship. That means c squared is x times c plus 2yc. What do you mean by that? X is just like a lambda, no, scalar, real number, and you know that it is positive. Initially they said x is positive, right? Then clearly if x is positive, then suppose x is more than 1, x can be more than 1 or less than 1. If x is less than 1, exactly on the line segment OC. Now z squared is on the line segment OC, right? Otherwise, if x is greater than 1, that means z squared is on produce OC. OC produce. Is it clear? Right?
Yes, sir.
Now C is like this. OC. Right? Now this complex number, if x is less than 1, then modulus of this one less than modulus of complex number represented by C, right? If x less than 1, exactly between O and C on OC, right? If x greater than 1, actually z squared is on OC produce somewhere here, z squared, or otherwise z squared is somewhere here, right? So better to say OC, then z squared is on the line OC or the line OC produce, right? OC produce, depending on magnitude of x, right? They are given x is positive, right? Okay. So you have alternative method for second part also. If y equals 2x, if y equals 2x, what is the argument of z squared? But argument of the line OC is, you know that we calculated angle argument OA squared theta plus tan pi by. So this is the alternative method, right? So I will explain it again. Alternative method. Forget to record it. Alternative. So you have alternative method for part 2, right? If y equals 2x, you can take argument of z equals theta, then tan theta equals y over x, that is 2. It's obvious, not we. Then theta equals from this construction, so this is a theta, right? If y equals 2x, this y, this x, this coordinate is xy. Y over x is tan theta, right? From this point. So now you can take therefore tan theta, then theta equals tan inverse 2. Then arc z squared equals arc c plus arc c, that is 2 arc c. That is 2 theta, that is 2 tan inverse 2. But arc c plus 2ic, that is from this diagram theta plus AOC. Argument of OC is theta plus this angle. This angle is AOC, right? AOC. Earlier we got the angle AOC. AOC is tan inverse 2, no? Because we got that tan AOC equals 2, right? Therefore, AOC equals tan inverse 2. This is also tan inverse 2, this is also 2 tan inverse 2. Therefore, arc c squared equals arc c plus 2ic. Right? Therefore, you can say then c squared is on the line OC or OC produce. OC produce from this also. But whether it is on OC or OC produce, it is clearly you can mention in previous method. In this method you cannot exactly say, but you can mention like this. Somehow it's on OC or OC produce, right? Right. What is the third part? Third part of this sum. Sketch the diagram. Sketch in a separate diagram a region consisting of point representing a complex number C, for which modulus of C less than equals 4 and tan inverse half less than equals arc C less than equals tan inverse 2, right? So you have to show this one. That is very simple. Modulus of C less than equals 4 and arc C greater than equals tan inverse half and less than equals tan inverse 2, right? So this is very simple. This is a circle, interior of a circle including the circumference of the circle, because this less than or equals 4, no? That is less than or equals 4 and equal sign also there everywhere, right? Equal sign also there. So how do you sketch diagram?
A circle from the origin with the radius 4.
Yeah, circle is the origin with radius 4. Right, this is 4, here minus 4, here also minus 4, 4i, here plus 4i, like that. Then tan inverse half is less than pi by 4 angle, no? Because half is less than 1. If it is less than 1, what is tan inverse? Tan inverse half, size of the angle, can you imagine? It is exact less than pi by 4 because tan inverse pi by 4 is, tan pi by 4 is 1, no? Angle like this, half angle, right? Then other one is tan inverse 2. Tan inverse 2 is more than 1, therefore that angle is more than pi by 4. These are two lines. First you have to, these are the auxiliary lines, so supporting lines for you to show this inequality, right? Supporting line, what is supporting line? Arc C equals tan inverse half. What is this line? This line is tan inverse arc C equals tan inverse 2, right? Tan inverse 2. Then required region is this region. This is the required region, right? You have to say the region including, because this between these two lines, because according to this inequality, and inside the circle. But here you use thick lines because everywhere you have equal sign also, right? Now you have to calculate the area. No, how do you calculate the area? Area of this area. If you take this area, how do you calculate the area? Can you tell me the area? If you take OPQ, the area OPQ,
So you see equation half r squared theta.
a half r squared theta. Half r squared is 4 squared. What is the angle between angle of this sector?
Tan 2 minus tan inverse 2 minus tan inverse half.
Tan inverse 2 minus tan inverse half. Right? This much. That 8 times tan inverse 2 minus tan inverse half. Okay? This one. Actually, you can simplify this one further, but that is not necessary because if you want, you can simplify very. You can put this one as a single tan inverse term, no? Single tan inverse term. You can set this one, no?
Yes, sir.
Very easily. The last part you have to find the area of this region, shaded region. That is angle between these two lines is this much. So you can leave the answer like this: 8 times tan inverse 2 minus tan inverse half, right?